Bismillahir Rahmanir Rahim. Welcome back, students. This is Hamza Noor, and in this particular video, I'm going to solve the question number 3 of International A-Level Edexcel P3 January 2022 paper. So, part 1 says that find in simplest form the integration of 2x minus 5 whole thing is raised to the power 7. All right. So, as you know, the fact that this indefinite integral is given to you in this form ax plus b whole thing is raised to the power n. You need to integrate this. So in order to integrate this, ax plus b whole thing raised to the power n plus 1 upon n plus 1 into a. Okay, n plus 1 is multiplied by a in the denominator, and then since this is an indefinite integral, so plus c. So in this case, we are given 2x minus 5 whole thing is raised to the power 7. We need to integrate this with respect to x. So therefore, 2x minus 5 whole thing raised to the power 7 plus 1 upon 7 plus 1, and this 7 plus 1 is multiplied by 2 and then plus c. So therefore, 2x minus 5 whole thing is raised to the power 8 divided by 8 times 2 and then plus c. So therefore, we can say that 1 over 16 into 2x minus 5 whole thing raised to the power 8 and then plus c. This is supposed to be our answer to part 1. And alternatively, what you can do over here is that since you know that this is the form of f dash x multiplied by fx raised to the power n, meaning we need to use the integration as the reverse chain rule method. So you need to consider fx raised to the power n plus 1. Since this part 1 was just a 2-mark question, so you know these simple steps are enough. Even if it was not a 2-mark question, you can still use these simple steps over here. Okay, but alternatively, what you can do, as you know that this is given to you in the form of f dash x multiplied by fx raised to the power n. So you will consider y is equals to fx raised to the power n plus 1. And first of all, you are going to find the dy over dx function. So n is basically 7. So y is equals to 2x minus 5 whole thing raised to the power 8. So first of all, find the dy over dx function, which is supposed to be 8 multiplied by 2x minus 5 whole thing raised to the power 8 minus 1, and then it is multiplied by 2. So therefore, we can say that dy over dx is equals to 16 multiplied by 2x minus 5 whole thing raised to the power 7. All right. So when y is equals to 2x minus 5 whole thing raised to the power 8, dy over dx is equals to 16 multiplied by 2x minus 5 whole thing raised to the power 7. And now, as we know the fact that integration is the reverse process of differentiation, so this essentially means that if you integrate 16 times 2x minus 5 whole thing raised to the power 7, if you integrate this with respect to x, what you will get? You will exactly get 2x minus 5 whole thing raised to the power 8. And since it is an indefinite integral, then plus c. But you don't need this constant term 16 over here. So in order to get rid of this constant term 16, you need to multiply 1 over 16 on both sides. All right. So therefore, you can say that the integration of 2x minus 5 whole thing raised to the power 7 with respect to x, it is equals to 1 over 16 multiplied by 2x minus 5 whole thing raised to the power 8 and then plus c. So you can attempt this question in both ways. The first method was quite simpler to do. But having said that, this integration, the integral in the form of f dash x multiplied by fx raised to the power n, you need to make sure that you have done a lot of practice before going in the paper, before going for the exam, because this particular type of method is very useful and it is very important, and at times it is the only option which you have when you need to integrate the complicated types of integration. Okay, so this was basically the part 1. So now let's move on to part 2. So in part 2, we need to integrate this 4 sine x divided by 1 plus 2 cos x with respect to x with upper limit pi over 3 and the lower limit is 0. and we need to show that the answer is in the form of ln a, where a is a rational constant to be found. So first of all, I'm going to erase the working of part 1 so that we can solve part 2 on this same page. All right. So here we can actually recognize that the integrand can be expressed in the form of f dash x over fx. And for that purpose, all you need to do is just adjust a constant term. As we know the fact that when we integrate f dash x divided by fx with respect to x, what we get is ln modulus of fx and then plus c. Okay, if you are dealing with an indefinite integral, but in this case we are dealing with a definite integral, so we won't add a constant term. See, so I've just mentioned a particular formula over here. All right, so if the integrand is actually in this form, if the integrand is itself existing in this form f dash x over fx, that's completely perfect. But if it is not exactly in this form, all you need to do is just adjust a constant term by multiplying or dividing. So in this case, what we are going to do, we will consider that fx is equals to 1 plus 2 cos x. All right. So what should be f dash x over here? F dash x should be, since the constant term 1 is differentiated, it becomes 0. And when you differentiate 2 times cos x, this will be 2 multiplied by minus sin x. So now we can say that when fx is equals to 1 plus 2 cos x, f dash x is supposed to be equals to minus 2 sin x. So now we can say that if the integrand was given to us in this form, that minus 2 sin x divided by 1 plus 2 cos x, we need to integrate this whole fraction with respect to x. So we would say that when you integrate it, you would get ln modulus of 1 plus 2 cos x. Okay, and integrating with the upper limit pi over 3 and the lower limit 0. So I'm going to write pi over 3 and the lower limit 0 like this. Okay, the upper limit is pi over 3 and the lower limit is 0. So now what you need to understand is that if the integrand was given to you in this form, minus 2 sin x divided by 1 plus 2 cos x, then you would have said that when you integrate this fraction, you would get ln modulus of 1 plus 2 cos x. But unfortunately, this is not the case happening over here. We don't need minus 2 in the numerator. What we need is, we need 4. What should we multiply minus 2 with in order to get 4? Obviously, we need to multiply minus 2. So we would multiply minus 2 on both sides. So now we can say that when we integrate 4 sin x divided by 1 plus 2 cos x with respect to x, we would get minus 2 multiplied by ln modulus of 1 plus 2 cos x. And in this case, we have a definite integral, upper limit pi over 3 and lower limit 0. So far, we have achieved this thing. Okay, so we have integrated. Now what we need to do, we need to put the upper limit and the lower limit respectively. So I'm going to continue the working on the top. All right. So minus 2 multiplied by ln modulus of 1 plus 2 cos pi over 3. And then you have a subtraction sign. And then you will open a new bracket. And here we will write minus 2 multiplied by ln modulus of 1 plus 2 cos 0. Okay. So far we have achieved this thing. So make sure to convert your calculator in radian mode. So 1 plus 2 cos pi over 3. This is supposed to be 2. So minus 2 times ln 2 and then a subtraction sign. And then you have 1 plus 2 cos 0, which is 3. So minus 2 ln 3. So therefore we can say that minus 2 ln 2 plus 2 ln 3. So therefore we can say that 2 ln 3 minus 2 ln 2. So if you take 2 as common, multiplied by ln 3 minus ln 2, and now what you can do, you can use the quotient law of logarithms. So 2 multiplied by ln 3 over 2, but we need our answer in the form of ln a. Okay, so this is exactly equivalent to ln 3 over 2 is squared. So when 3 over 2 is squared, it becomes 9 over 4. Therefore, ln 9 over 4, and we have found our answer in terms of ln a. Therefore, a is equals to 9 over 4. So in this way, you are going to attempt this part 2. So this was International A-Level Edexcel P3 January 2022 paper, question number 3.